Morning guys, hope everybody is doing well today. I'm gonna put out a video here. Might be a little bit lengthy, but we're gonna discuss we've gone so far as to know how we're able to detect which primary line is faulted in an underground primary system by using high pot sticks when we're going from transformer to transformer, and also using fault indicators, which are going to show on each transformer. And what I've been promising to do here is show you how to restore power after you have found the faulted span. If you look in the ELW channel, I did put out excuse me, a short video of an underground dip that I had found in Surfside with 3 transformers in it. And it's one where I showed where I went down the street and then came back up the street and showed you an underground dip. 2 dips that are on one pole fed by one phase. So I'm going to use that same drawing and schematic here of what I drove through on that day. So if you want to reference back to that video, that's a good one to look to see what was actually out there in the field and what we're going to go over with today. All right. So what we had here, and sorry for the back of my head in some of these cases, we had an overhead span that came across the road. And if you'll see in the video, there were 2 switches mounted on each side of the pole, and you had 2 different dips. And like I told you before in the video, that's a great indication to let you know that you have a loop-fed underground system going on in there. So I drove through and I saw T1 and T2 on the right-hand side of the road. Then I turned around and came back, and T3 was on the other side of the road. And marked on the outside of the T3 transformer was this: normal, open point. Now remember, in loop-fed systems, we don't have it looped all the time. It doesn't stay looped. We have the capability to loop. So that's why we have to have an open point in this situation right here, and we have an open point in all loop systems to be able to backfeed. So that would be a good question there. In a loop system, underground system, do you have to have an open point? The answer to that would be yes. It's also normal practice here that in our normal open point, we're not going to put it on this side of T3. If we fed all the way around, and this is my feed direction, if you watch the arrows here, this dip came off and feeds this direction to T1, this direction to T2, around the back, and this direction to T3. If I fed the transformer inbound on A here, I would have no indication if this cable ever faulted. All the power in the subdivision to these units that were over here on the side of the road. This is 10th Avenue over here. All of these units would be fed from these 3 transformers from one dip. If I had a failure in this cable, nobody would ever know about it because no power would be out. So I'm always going to use at least 1 transformer, and this could be, just to let you know, this could be up to 10, 20 transformers in a loop. I'm always going to have at least 1 transformer in my loop energized from the other dip. Now do keep in mind, and this is why I want to keep this one kind of simplistic here, I'm using 1 phase of primary overhead coming in. So I know my phases are going to match. And we're going to say, just for goodness sake, it's A phase. Okay. So we know our normal open point is this direction, and I'm going to go through the two different methods, both the underground fault indicator method and the high potty method, to show you what you're going to do actually out there in the field when you come up. All right. You drive up to this situation, and you come over here, and this fuse is blown. This is with fault indicators. When you're driving through here, You drive up 10th Avenue, you see the fuse is blown. Your first thing to do is here, you're going to turn in the complex, and you should have a red. All right, and I'm putting these in there just as scenarios. All right, you're going to have white here. So my question would be on the quiz right here, in which span is it faulted? Obviously you're going to find out because I'm going to go through the entire situation. So we know from previous videos here, I always stay in between the red and white span. Somewhere in this vicinity, somewhere in this area, I have a faulted span. Now we'll go on to the process of backfeeding. This is where this gets kind of difficult in the explanation and kind of lengthy right here. In order for me to isolate this span, I don't want to energize it. Remember, I'm not out there to repair it. I'm the service guy and I'm the line technician that came out here on the trouble call, but I do want to get power back on, and that's the great convenience and great attribute we have to restore power and not actually have to repair it at that time. We want to get power restored quickly. All right, so let's go T1 and T2. Let me check my video to make sure you guys are able to see this off to the side. Yes, sir, you are. All right. In T1, I have the inbound A and the outbound B bushings. This is not phases. In T2, I have the inbound A and the outbound B bushings. All right. Take a look at that. You might want to note this right here because I'm going to erase it in just a moment. In order for me to get this isolated and out so it will not be re-energized again, I have to look at T1. Here's my direction of electricity. It goes in on A, put an X here for faulted. It comes in on A and out on B. I need the outbound cable going this way, isolated. So we're going to go park B. That's the outbound. All right. Now that I progressed on to T2, this wire going this direction is coming in on the T2. I need to isolate it from this span right here also. So I'm going to go over to T2A. Park. Oops, sorry about that. A. Just a short explanation here. If you've kept up with the videos and you've kept up with the quizzes and whatnot, you know what parking is. Parking is using that one bushing parking stand, mounting it in the transformer, and moving that inbound cable elbow that went in on A and parking it. Parking it is dead ending the conductor and isolating it. So I'm going to mark my map to what I've just completed here. Park B, which is the outbound. So I've dead ended it. I'm going to park A, which is the inbound, here. And you'll notice inbound, outbound, inbound, outbound. So at this time, with fault indicators that I've been using, I've isolated that span of cable. I'm in great shape right now. All right, that's still the faulted span. We're just going to leave that in that type of situation. All right, so with this span of cable isolated at this time, I now need to restore power. So how will I do that? One, now that my power can no longer travel along this line, I've dead ended it, we're going to replace fuse. And close it. All right, so I have now reclosed this fuse and I have power going to T1. It is restored. T2 is still without power. I do have power. This was never affected because this fuse never blew in the first place. I still have power from here to here. Now I need to get it from here all the way back to this transformer. And that's why they call it backfeeding. What normally used to go this direction, I'm now going to backfeed back this direction. So how would I do that? I've got the inbound here on A. I've got the outbound on B that's normally parked right here. I'm going to close T3B. And the reason why I designate that is the T3, transformer 3B bushing. All right, once I've done that, my power flow direction has changed, which is okay. Now I'm coming around this direction and backfeeding, feeding backwards into the transformer. This transformer is now restored. So for the temporary situation, I know we've always said, well, we need to have the inbound cable on bushing A and the outbound cable on bushing B. This is just temporary to restore power. I'm actually coming in on A, out on B this direction, and in on B. And I hope that makes sense to you. It used to be in on A. I've got to come in on B now on this transformer just for the temporary time. See if there's any other details that I want to add to that. Okay. So in summary, faulted span between R and W fault indicators. That's between T1 and T2. That means I need to isolate the cable in between those two. In T1, I park B. That isolates it from going any further. In T2, I park A. That isolates it from being re-energized from the other direction. I replaced the fuse. I have now restored power to T1. Can't go any further because I've parked the elbow that's going outbound, and I've closed it. To get power backwards or back feed into T2, I now have to close T3B. It's normally open before. Remember those hash marks that I had back here, and I'm feeding backwards into T2. So you're gonna see that scenario come up on a quiz right there. I'm gonna have you just go through these steps simplistically. So it'd be good to reference this video multiple times if you have to. And I might, of course, you know me, I might change your faulted span to this one or this one. Do you remember? I want to remember, you got to remember this hint all the time. My first fault indicator is the fuse. It's not going to be a fault indicator that you see mounted in a transformer, but it will indicate that I have a fault on my entire system. Just to go back for just a moment to give you that scenario. I drive in. This fuse is blown. I have white, white, and white. We know immediately this is my first fault indicator right here. The fuse is blown, is that I have a bad span between the dip pole and the first transformer. Okay, let me get some erasing going on. It will let you know. As far as using and isolating underground and backfeeding via fault indicators is very fast and very easy. There's really only about 4 steps going on here that you need to do. And consider that if you're working with a lineman on a service truck, he's going to drive up here in this situation, and you'll be communicating back and forth by radio. He's going to drive up here, set his service bucket up, go ahead and go up and start replacing the fuse in preparation, not closing it, replacing it in preparation for what's going on. And you're going to come out of the truck and walk into the subdivision. Well, I've got a white and a white. Then you can tell your lineman out the road, hey, I've got 2 white indicators at T1 and T2. Looks like it's in the first span coming off the dip pole. Then you guys are just going to team up together and come in, isolate the span, and backfeed. It's going to be a team effort. I want you guys to know and understand what the processes are here in those situations, and nothing is done. Let me reiterate this on the safety side. Nothing is done as far as opening fuses, closing fuses, closing open points without communication with your coworker. Even if you're face to face or 100 feet away or 100 miles away, you've got to communicate with your coworker that you're doing something in a transformer or you're doing something at a dip pole before you energize or de-energize anything while you're working. So when I go over here and he's changed this fuse and he just has it hanging, he hasn't closed it yet. You're going to go to T2, prepare your open point. Call Lyman Shoemaker on the radio. Hey, Jacoby, I just opened up T2A. It is now open. And Jacoby's going to answer back, Roger that. And Jacoby's going to call me. Scott, I just opened T1B. It's now open. I'm going to say, Roger that. Jacoby's going to go out here with the extension stick. And he said, Scott, are you in the clear? I'm ready to close the switch. And I'm going to answer back on the radio, yes, I am ready for you to close. So everybody stands in the clear while you're closing the switch. So on and so forth through the entire operation. Now I've restored, power up to here. That was with the red and white situation. Now I've restored power to here. And Jacoby comes in and he says, let's go over and meet at T3. All right. So we meet over at T3, both of us together. And I opened the transformer up and I said, Jacoby, we've got to take and pull the elbow off the parking stand of T3 and close at T3. And Jacoby's going to say, okay. And he's going to do that while we're standing there together. So safety in these situations is paramount, that you have communication for all processes that you do in underground. You're relying on whoever installed it. So there are plenty of situations where you're going to see and go out there in the world, all these transformer inbound and outbound cables are tagged from dip pole to T1, from T1 to T2, and from T2 to T3. That's a tag that's actually going to go onto the cable. Don't trust those. They're a good guide. They're a good reference, but do not trust those 100%. And that's why we have to have good communication between one another and keep clearances, stand away from things while people are opening or closing switches or energizing cable. Okay, so let me get some erasing going on here. Okay, hope you guys are doing good. I'll tell you one thing, I'm tired of being cooped up in the house right here, that's for sure. But I am making my normal visits to Wendy's. Delivery costs too much. Okay, let me get this back right. Now, high potting, there's a lot more work involved. We're going to use the same scenario in this situation. All right, we drive up, same fuse is blown, okay? And it is on single phase. So, get rid of this. All right, we have no fault indicators in our system here whatsoever in our underground loop. The fuse blown equals our first indicator. All right, in order for us to high pot from the dip pole to the transformer, you've seen in previous videos, the rule that I must use, the procedure I must use is I must isolate the cable going into the transformer first before I can test it. Which is the inbound cable? T1A. T1A, park. Okay, so we parked the cable in T1A, it's isolated. What are we going to do next? Test. And you remember the picture that I showed you in the PowerPoint presentation. I'm able to put the high pot adapter on the sticks and test from the top of the switch to the bottom of the switch. All right, safety again. You do not, he's going to call me. I'm getting prepared to test. And you test, you stand back, you stand in the clear while he's testing. All right, the conductor tests good. We're going to use that scenario all the way through so you guys get the processes of how it goes on as far as leapfrogging across transformers. All right, T1 tests good. So the next thing we're going to have to do is, I've got this span complete, is this is going to be my next span that I'm going to test. So I need to get it isolated and prepared for high pot testing. All right, so T1B, you install on Feedthrough. All right, if you remember, we've got to have a feed-through in this transformer to be able to get one energized bushing on the transformer and one to put the stick on. This is why we have to install T1B on a feed-through. All right, I've got to have this conductor isolated going to T2 because, and dead end and isolated because I can't test through a transformer. All right, so I need to T2A park. Okay, hope you're keeping up so far. I told you it gets kind of difficult. And if you want to draw in the hash marks, I mean, if you want to draw this out, draw in hash marks, I've got now this dead ended, and this is on a B, T1B is on a feed through. All right, now I need a power source to be able to use my sticks. So T1A to transformer, and this is XFMR, is the abbreviation for transformer in the industry. So I've moved my elbow over to the transformer. At this point, I have B off. T1B is on the feed through, so you can't go any further in that direction. And I've got T2A parked, so it is isolated. I need power now. Okay? Close fuse. All right. So now I have power to this transformer. B is on the feed through, going this direction. It is now isolated. I'm really in preparation to go ahead and test the next span. So, high pot. T1B to T2A. So I'll pause for just a moment there if you want to look at your notes. Take this into your notes. Fuse, first indicator, T1A park, T1B is on the feed through, T2A park, T1A to the transformer, close the fuse, high pot T1B outbound to T2A, which is isolated in the parking situation. All right, it tests good from here to here. So now that I've got this one parked here, I know I'm going to need to test the next span. So I move T2A. Let me go back here. T2B to feed through. I don't want my power to go any further over here. I need to move, T2A is parked, I'm going to need power at this transformer. So I put T2A on the transformer. All right. Still haven't got power here yet because I had it on the feed through before. T1B to transformer. Now I've energized the cable up to this point right here. The T2B outbound is isolated because I have it on the feed through, and T2A is on the transformer right there, so I'm able to energize the transformer. So in these steps right here that I've done, I've been able to get power from here to here and isolate from here to here. All right, so good. We're good to go. Now, here's the simplistic part of this. We're going to go ahead and move on to 3. I might have to make some erasure marks right here, and I'll probably go over to the other side and get it squared away over here. These sequence of steps right here, starting right here, are just now continuous with the change of numbers. That's why they call it leapfrogging. If I need to carry on to T3, which we're going to do, I'll do all of these in sequence just the way you see it. So up to this point right here, this is a little bit different because I had to come off a dip. From this point on, all I need to do is change numbers in this situation. So we're going to go ahead and do that. I don't know, this tested good, we energize it. I don't know if it's between here and here. So here's what you're going to do. Watch these numbers. I'm just going to do this. Watch high pot, T2B, T2A, T1B. So watch. High pot. T2B now changed to T3. T2B now changed to T3. T2 now changes to T3. T1 now changes to T2. All I've done is gone up sequentially in the numbers right here. 2, 2, 1, 3, 3, 2. And carry on with what you got there in the next part right here. All right, so I've high potted. These is a change in numbers too. T2B to T3A. Sequential number up. T1 now changes to T2. T2 now changes to T3. T3B equals feed-through. Sorry for the noises right there. T3A equals transformer. T1B equals now T2B equals transformer. Okay? So if you had the 4th transformer, all you'd have to do is rank up in numbers again. So say I've got a 4th transformer in this line. High pot T3B, T4A. T4B goes to the feed through. T4A goes to the transformer. T3B goes to the transformer. And on and on and on. The sequential numbers just keep going up. Now, as stated before, when you're high potting, you've got to communicate with the guy that you're high potting to. In leapfrogging, one lineman's here, one lineman's here. When this span is re-energized and done, one lineman's here and one lineman's here. They're in the preparation, getting things on feed through, and communication, like I said, is going back and forth between them at all times, especially when I'm testing the cable, high potting it, and when I'm putting it on a transformer to energize it. So, like I said before, if we go to the 4th transformer, we just go up a single number. All right. So now you've had 2. 1 is the fault indicator way, how to isolate, and 2 is the high potting method with no fault indicators. Once you have identified, and we're going to go back on that, I'm going to take all of this out, but do write it down, because this is the processes and you'll be quizzed. I'm going to give you a quiz that says I have no fault indicators and I've high pot. I'm going to ask you to high pot and re-energize as you go. That's what we're doing here, from T1 to T2 to T3. You're looking at it. Obviously, you got it right here, but I want you to know the steps as far as that is concerned. All right, so I'm going to erase all this off the side, these two sides right here, and go on the restoration part. Hi, honey.
Hi.
That's one good thing about being home. All right, so wherever you're at in the processes of doing your fault indicators, your high potting process, and you come to the point where you check the span with the high pots and determine it's bad through the high pots, we'll use another alternate situation here. This is how you're going to go ahead and restore. When I ask you the question on the quiz today, I'm going to ask you the scenario of the red, white with fault indicators. I want you, one, to isolate it, and this will be in the question text. I want you, one, to isolate it and restore it. So isolate steps and restore steps. And what I'll do is I'll ask that in two separate questions. When you're using high pot adapters, I'm going to give you the scenario that the underground here is bad between T1 and T2. How to restore it. First, you're going to show me the steps of how to find out between T1 and T2 that it's bad. Those are the steps that you had seen before. And then I'm going to ask you to restore it. That's going to be another separate question. So, we've come out here, we've had our fuse blown. First indicator. Okay, we're going to high pot to T1. Done that. I've listed all those steps out. You should have those before. And we have determined that this is the faulted span. Hold on one second. All right, pardon that. And we have determined with the high pot sticks that this is the faulted span. This was our normal open point that stayed there all the time, every day of the week. How do I first isolate it and restore? So isolate first. All right, here's the simple process right here. T1B with the high pots. This tested bad, but remember to do that. Remember when we have to do high potting, we had to put T2A